What if I told you that humanity could one day spread across an area so vast that light itself would take 100,000 years to travel from one end to the other? What if our species could inhabit not just planets, but entire star systems scattered across a cosmic neighborhood containing over 200 billion suns? If you enjoyed this mind-bending thought, hit that like button. Also, 99% of you that watch our videos are here to subscribe, so kindly hit the subscribe button. It helps our video reach more people who enjoy content like this. Welcome to a journey that will completely shatter your understanding of scale, space, and what it truly means to be human. Today we're exploring what would happen if humanity became a galaxy-spanning civilization. And trust me, by the end of this, your brain will never think about our place in the universe the same way again. But first, we need to understand something that will blow your mind. Just how incomprehensibly, impossibly, ridiculously huge our Milky Way galaxy actually is. Right now, as you're listening to this, you're sitting on a tiny rock, hurtling through space at 67,000 miles per hour. But that rock, our Earth, is just a microscopic speck in something so vast that human language doesn't even have adequate words to describe it. Dr. Sarah Johnson from NASA's Goddard Space Flight Center puts it this way: when we talk about the enormity of the cosmos, it's easy to toss out big numbers, but far more difficult to wrap our minds around just how large, how far, and how incredible these distances really are. Let me give you some numbers that will make your head spin. The Milky Way galaxy has a diameter of approximately 87,400 light-years, according to recent measurements, though some estimates suggest it could be as large as 100,000 light-years across. But what does that actually mean? A light-year is the distance that light travels in 1 year. Light moves at 186,282 miles per second. That's fast enough to circle the Earth 7.5 times in a single second. In 1 year, light covers about 6 trillion miles. So when scientists say our galaxy is 100,000 light-years across, they're telling you that if you could somehow travel at the speed of light, the fastest possible speed in the universe, it would take you 100,000 years to cross from one side of our galaxy to the other. But here's where it gets absolutely insane. You can't travel at the speed of light. Nothing with mass can. The fastest spacecraft humans have ever built, the Parker Solar Probe, travels at about 430,000 miles per hour at its peak speed. That sounds incredibly fast until you realize that at that speed, it would take you over 6.5 million years just to reach the nearest star to our Sun. To cross the entire Milky Way at our current fastest spacecraft speed would take approximately 1.5 billion years. That's longer than complex life has existed on Earth. Let that sink in for a moment. The thing we casually call our galaxy is so mind-bendingly huge that traveling across it at our best current technology would take longer than the entire evolutionary history, from the first primitive cells to human civilization. But the scale gets even more incomprehensible when you consider what's actually inside this cosmic monster. The Milky Way contains approximately 200 billion stars. 200 billion. That's roughly 27 stars for every single person currently alive on Earth. Each of those stars is a massive nuclear furnace, most of them larger than our Sun, many of them surrounded by their own planetary systems. Recent research suggests that most stars have planets, which means our galaxy likely contains over 1 trillion worlds, 1 trillion planets scattered across this vast cosmic disk, each one a potential home for life, for civilizations, for stories we can't even imagine. Dr. Michael Torres, an astrophysicist at the European Southern Observatory, recently published research showing that estimates for the Milky Way's size have varied greatly throughout history, from 100,000 to 1.9 million light-years in diameter. The challenge is that we're trying to measure our galaxy from the inside, like an ant trying to figure out the size of a football stadium while sitting on the 50-yard line. But here's where your mind is really going to be blown. The Milky Way isn't alone in the universe. It's part of something called the Local Group, which contains about 80 galaxies, including our nearest major neighbor, the Andromeda Galaxy. And the Local Group? It's just a tiny suburb in something vastly larger called the Virgo supercluster, which spans approximately 110 million light-years across and contains over 1,300 galaxies, including our entire Local Group. But wait, it gets even more mind-shattering than that. Recent discoveries by astronomers have revealed that our Virgo supercluster is itself just a small part of an even larger structure called the Laniakea supercluster, which spans 520 million light-years and contains over 100,000 galaxies with a total mass of 100 quadrillion suns. And even that isn't the end of the cosmic hierarchy. Researchers have now discovered what they're calling Quipu, a cosmic superstructure that is more than 13,000 times the length of the Milky Way, with a mass 200 quadrillion times that of our Sun. This structure, along with 4 others recently discovered, contains 45% of the galaxy clusters, 30% of the galaxies, and 25% of the matter in the observable universe. Think about that for a moment. We've gone from your neighborhood to your city, to your country, to your planet, to your solar system, to your galaxy group, to your supercluster, to your supercluster. And we're still not done with the hierarchy of cosmic structures. The universe is organized like a vast cosmic web, with filaments that span between several hundred million light-years to 10 billion light-years, covering more than 5% of the observable universe. These are literally the largest known structures in existence. Now imagine humanity spreading not just across our Milky Way galaxy, but potentially across this entire cosmic web of structures. The possibilities become so vast that they transcend our ability to comprehend them. But let's take this mind-bending scale and imagine something truly extraordinary. What if humans didn't just live on one tiny planet in this cosmic vastness? What if we spread out across the entire galaxy? What if humanity became a truly galactic civilization? This isn't just science fiction anymore. Serious researchers are studying exactly this possibility. The concept of galactic civilizations has been formalized by scientists through something called the Kardashev scale, developed by Soviet astronomer Nikolai Kardashev in 1964. This scale measures a civilization's technological advancement based on the amount of energy it can harness and use. A Type I civilization can harness all the energy available on their home planet. A Type II civilization can harness the entire energy output of their star. But a Type III civilization, that's when things get truly incredible, can harness the energy of their entire galaxy. Humanity currently ranks at about 0.7 on the Kardashev scale. We're not even a Type I civilization yet, but researchers like Dr. Michio Kaku predict that we could reach Type I status within the next century or two, Type II within a few thousand years, and Type III within 100,000 to a million years. Imagine that. In less than a million years, a blink of an eye in cosmic terms, humanity could theoretically harness the power of 200 billion stars. But what would a galaxy-spanning human civilization actually look like? How would it work? How would people live? How would they communicate? How would they govern themselves across distances that make our current concept of long distance seem like a joke? Let's start with the basics. Getting around. In a galactic civilization, travel would be fundamentally different from anything we can imagine today. Even with hypothetical faster-than-light travel, crossing the galaxy would be a major undertaking. But here's where recent scientific breakthroughs become incredibly exciting. Researchers are actively working on revolutionary propulsion technologies that could make interstellar travel not just possible, but practical. Dr. Robert Forward, a physicist who spent decades studying interstellar travel, calculated that even with perfect fusion rockets, engines that convert matter into energy with 100% efficiency, it would take about 12 years to reach 10% of the speed of light, and then 40 years to reach the nearest star system. But new concepts are emerging that could change everything. The Bussard ramjet, first proposed in the 1960s, would collect interstellar hydrogen using powerful magnetic fields and use it in a nuclear fusion process to propel spacecraft forward. Recent calculations show that such a system would need a magnetic field stretching 150 million kilometers, an engineering challenge that would require the resources of an entire star system. Even more exotic are proposals for laser-powered ramjets and fusion runway concepts. These systems would use precisely placed fuel deposits or laser stations throughout interstellar space to provide continuous acceleration, potentially allowing spacecraft to reach significant fractions of light speed. NASA is currently researching breakthrough propulsion architectures using kilometer-scale, multi-hundred megawatt, phased array lasers to beam power 2 vehicles for interstellar precursor missions. But even with these advanced technologies, crossing the galaxy would still take hundreds of thousands of years. This means that in a galactic civilization, travel wouldn't be like hopping on an airplane. It would be more like the great human migrations of prehistory, except instead of walking across continents over generations, families and communities would voyage across light years over centuries or millennia. But here's where it gets interesting. This might actually be a feature, not a bug. Dr. Carl Sagan once wrote that the vast scales of the universe might be nature's way of ensuring that different civilizations have time to mature before they encounter each other. In a galactic human civilization, different star systems would develop their own cultures, technologies, and ways of life over thousands of years of isolation. Imagine the diversity. Earth humans living on water worlds might develop into something resembling aquatic species. Humans on high-gravity planets might become incredibly strong and compact. Humans living in zero-gravity space habitats might become tall and slender, with enhanced spatial thinking abilities. After thousands of years of separate evolution, both biological and cultural, these different branches of humanity might become as different from each other as modern humans are from our ancient ancestors, but they would still be connected by something incredible: a galactic communication network. Even though travel would take centuries, communication could happen much faster. Radio waves and laser communications travel at the speed of light, which means messages could cross the galaxy in 100,000 years. That might sound impossibly slow, but think about it in historical terms. 100,000 years ago, modern humans were just beginning to spread across Earth. All of recorded human history has happened in the last 5,000 years. So a message sent from one side of the galaxy to the other would arrive in about 20 times the length of all recorded history. But for a galactic civilization that plans in terms of millennia and centuries, this would be manageable. They might develop a kind of galactic internet where information, stories, scientific discoveries, and cultural achievements slowly propagate across the galaxy like waves spreading across a cosmic ocean. Dr. Frank Drake, who pioneered the search for extraterrestrial intelligence, calculated that a galactic communication network could allow civilizations to share knowledge across the entire galaxy within a few 100,000 years. Any major discovery or breakthrough made on one side of the galaxy would eventually reach every other inhabited world. This creates an incredible possibility. A galactic civilization could potentially accumulate knowledge and wisdom for millions of years, creating a collective intelligence that spans an entire galaxy. But the communication challenges would be staggering. Imagine trying to have a real-time conversation when your message takes 50,000 years to reach the other person, and their reply takes another 50,000 years to get back to you. Your great-great-great-grandchildren would receive the response to a question you asked in your youth. This would fundamentally change how information is shared and decisions are made. Instead of quick back-and-forth exchanges, communication would become more like launching messages in bottles into a cosmic ocean, hoping that someone, somewhere, somewhen would find them meaningful. The very nature of knowledge sharing would evolve. Rather than sending simple messages, galactic humans might develop incredibly sophisticated information packages, complete databases of culture, science, art, and wisdom that could sustain entire civilizations for millennia while they waited for the next communication. These cosmic data packets might contain entire libraries, complete musical traditions, detailed scientific theories with thousands of years of experimental data, and philosophical treatises developed by minds that had centuries to contemplate deep questions. Imagine receiving such a package from a civilization 30,000 light-years away. Opening it would be like archaeologists discovering the Library of Alexandria, except instead of one human civilization, you'd be accessing the accumulated wisdom of dozens of worlds and thousands of years of development. But how would such a civilization govern itself? This is where things get really fascinating. Traditional forms of government simply couldn't work across galactic distances. You can't have a democracy where it takes 50,000 years for votes to reach the capital. You can't have a centralized monarchy where royal decrees take longer to deliver than the entire evolutionary history of human civilization. Instead, a galactic civilization would probably be more like a loose confederation of independent systems connected by shared culture, technology, and long-term goals rather than day-to-day governance. Dr. Gregory Benford, a physicist and science fiction writer, has studied this problem extensively. He suggests that galactic civilizations would probably organize around what he calls lighthouse civilizations, advanced systems that serve as beacons of knowledge, culture, and coordination for surrounding regions of space. These lighthouse systems might be home to massive space habitats, artificial intelligences, or post-human entities that could think and plan on timescales of thousands or millions of years. They would coordinate the slow, patient work of galactic civilization, seeding new worlds, sharing knowledge, and maintaining the long-term infrastructure that connects hundreds of billions of star systems. The governing structure might resemble something like medieval feudalism, but operating on galactic scales and cosmic timescales. Local star systems would have complete autonomy for day-to-day decisions, but would participate in galaxy-wide projects and follow broad cultural and ethical guidelines that slowly evolve over millions of years. Decisions that affect the entire galaxy would be made through incredibly patient consensus-building processes that might take hundreds of thousands of years to complete. But once made, these decisions would have the stability and permanence to guide civilizational development for millions of years. But let's talk about what daily life might be like for ordinary people in such a civilization. Imagine being born on a world orbiting a red dwarf star, 30,000 light-years from Earth. Your planet receives most of its energy from massive orbital solar collectors that beam power down from space. The sky is a perpetual deep red, and the star never moves. Your world is tidally locked, with one side always facing the sun, and the other in eternal darkness. Your ancestors arrived here 800 years ago on a generation ship that took 6 centuries to make the journey from their previous home. They brought with them the accumulated knowledge of 1,000 worlds and 10,000 years of human experience across the galaxy. You grow up learning not just the history of your own world, but the stories of dozens of other human civilizations scattered across nearby star systems. You learn about the ice miners of the Vega system, who live in massive cities carved into frozen moons. You hear tales of the cloud riders of the gas giant Kepler 442b, who live in floating cities in the upper atmosphere and have never set foot on solid ground. Your education includes the great songs that have traveled across the galaxy, musical traditions that began on Earth 50,000 years ago and have been modified and enhanced by hundreds of civilizations as they spread from star to star. You learn mathematical concepts first discovered by minds, on worlds whose names are forgotten, and philosophical insights that have been refined by thousands of years of contemplation, by beings who may no longer be entirely human. When you come of age, you face a choice that no human in our current civilization could imagine. Do you stay on your birth world and contribute to its development, or do you join one of the great voyages to seed life on a new world? These voyages would be the great adventures of galactic civilization. Imagine signing up for a journey that will take 4 centuries, knowing that you'll spend your entire life aboard a ship traveling between the stars, and that it will be your great-great-great-grandchildren who finally arrive at the destination and plant the seeds of a new world. But that journey would be far from boring. Generation ships in a galactic civilization would be massive, potentially containing millions of people living in rotating habitats that simulate gravity. These ships would be like traveling worlds, complete with their own ecosystems, cultures, and technologies. Dr. Charles Pellegrino, who has designed theoretical generation ships, estimates that a proper interstellar arc might be hundreds of miles long and house up to 10 million people. During the centuries-long journey, entire civilizations would rise and fall within the ship. People would be born, live complete lives, and die having never seen anything but the inside of their traveling world. These generation ships would become laboratories for human development. Cut off from outside influence for centuries, the people aboard would develop their own unique cultures, technologies, and possibly even evolutionary adaptations. By the time they arrived at their destination, they might be substantially different from the humans who originally launched them. The ships themselves would be marvels of engineering that dwarf anything we can currently imagine. They would need to be completely self-sustaining for centuries, recycling air, water, and nutrients with perfect efficiency. They would need massive libraries containing all human knowledge, workshops capable of manufacturing any needed technology, and genetic banks preserving the diversity of Earth life. But perhaps most importantly, they would need to maintain the cultural and psychological health of populations that would spend their entire lives in artificial environments, working toward goals they would never see completed. The social engineering required for such voyages would be as challenging as the technical engineering. How do you maintain motivation and purpose across generations of people who will never see the promised land? How do you prevent social collapse or psychological breakdown during centuries of confinement? Some researchers suggest that generation ships would need to be organized like small nations, with their own governments, economies, and social institutions. Others propose that they might be organized around specific missions or beliefs that give meaning to the long journey. The cultural developments aboard generation ships would be fascinating to observe. Imagine art forms that are specifically designed for life aboard a traveling world. Music that incorporates the sounds of the ship's engines. Visual art that works with the curved surfaces of rotating habitats, stories and myths that celebrate the journey itself rather than the destination. Languages might evolve and change during the voyage, creating new dialects or even entirely new languages by the time the ship reaches its destination. Religious and philosophical beliefs might develop that are specifically suited to life in transit between the stars. Children born aboard generation ships would have a fundamentally different relationship with space and time than any humans in our current civilization. They would grow up knowing that their entire world is traveling through the void, that their ultimate purpose is to seed life on a distant world they'll never see, and that they are part of a project that spans centuries and connects them to millions of other humans scattered across the galaxy. But the most incredible part of a galactic civilization might be what happens to human consciousness itself. Living across such vast scales of space and time would fundamentally change how humans think about themselves, their lives, and their place in the universe. When your civilization spans 100,000 light years and plans projects that take 1,000,000 years to complete, your perspective on life becomes radically different. Dr. Nick Bostrom, a philosopher who studies existential risk, has written about how expanding across the galaxy would change human psychology. Instead of thinking in terms of individual lifespans, people would begin to think in terms of civilizational lifespans. Instead of focusing on personal achievement, they might focus on contributions to million-year projects that will benefit humanity thousands of generations in the future. This kind of thinking already exists in some forms today, when scientists plant slow-growing trees that won't mature for centuries, or when they build cathedrals that take generations to complete. They're engaging in a kind of transgenerational thinking that would be essential for a galactic civilization. But a galactic humanity would take this to incredible extremes. They might undertake projects like moving entire star systems to more favorable locations, or building massive structures that collect energy from supermassive black holes, or even attempts to influence the large-scale structure of the galaxy itself. One of the most mind-bending projects that researchers have seriously considered is called stellar engineering, the deliberate modification of stars to extend their lifetimes or change their properties. Dr. Dan Hooper from Fermilab has calculated that an advanced civilization could potentially extend the lifetime of stars by orders of magnitude by carefully removing mass from them and controlling their fusion processes. A galactic civilization could theoretically keep stars burning for trillions of years instead of the usual billions, extending the potential lifetime of the galaxy as a habitat for life. Even more incredibly, they might attempt to move stars themselves. The concept, known as stellar lifting, would involve using powerful magnetic fields and directed energy to gradually move entire star systems to more desirable locations. Why would you want to move a star? Well, stars in the outer regions of the galaxy orbit more slowly than those near the center. Over hundreds of millions of years, star systems can drift apart as they follow different orbital paths. A galactic civilization might want to keep important star systems grouped together or move them away from dangerous regions like the galactic center where radiation levels are high. Dr. Matthew Kaplan from Illinois State University has calculated that with advanced technology, it might be possible to move our entire solar system using a stellar engine powered by the sun itself. The process would take millions of years, but it could allow a galactic civilization to literally rearrange the galaxy to suit their needs. Think about that for a moment. A truly advanced galactic civilization wouldn't just live in the galaxy. They would renovate it, customize it, and optimize it for life on scales we can barely comprehend. They might create vast networks of artificial stars to provide energy and light in the empty spaces between natural star systems. They might build enormous structures that span multiple star systems, creating galactic-scale habitats that could house quintillions of beings. They might even attempt to manage the galactic ecology itself, preventing stellar collisions, controlling the formation of new stars, and managing the flow of matter and energy throughout the galaxy to create optimal conditions for life and consciousness. But perhaps the most incredible aspect of a galactic civilization would be the diversity of human experience it would create. Right now, all of humanity lives on one small planet, orbiting one ordinary star. We all experience the same type of gravity, the same type of atmosphere, the same day-night cycle, the same seasons. Our entire species has developed within an incredibly narrow range of environmental conditions. But a galactic civilization would experience everything the universe has to offer. Some humans might live on planets orbiting binary stars, experiencing double sunrises and sunsets with complex seasonal patterns that cycle over decades. Others might live on planets with extreme axial tilts, where seasons last for decades and the temperature difference between summer and winter is hundreds of degrees. Some might live on tidally locked worlds, where one side is always day and the other always night, creating permanent twilight zones between the hemispheres where the temperature and lighting are just right for human habitation. Others might live on planets with unusual atmospheric compositions, worlds where the sky is green or purple or gold, where aurora displays are visible every night, or where the atmospheric pressure allows humans to fly with simple wing attachments. Some might live on ocean worlds with no land at all, developing floating cities and underwater habitats. Others might live on desert worlds, ice worlds, or worlds covered in vast forests of alien vegetation that turns strange colors with the seasons. But the most exotic humans might not live on planets at all. They might live in space habitats, massive rotating cylinders or spheres that create artificial gravity through centrifugal force. These habitats could be custom designed for optimal human living conditions with perfect weather, ideal gravity, and carefully designed ecosystems. Dr. Gerard K. O'Neill who pioneered the study of space habitats, calculated that a single space colony could house up to 20 million people in an environment more pleasant and controlled than any natural planet. A galactic civilization might contain billions of such habitats, each one a unique world designed by and for its inhabitants. Some space habitats might be enormous, larger than planets, with internal surfaces that stretch for thousands of miles. Others might be small and intimate, designed for specific communities or purposes. Some might simulate Earth-like environments perfectly, while others might create entirely new types of environments that are impossible on natural worlds. Imagine space habitats with internal weather systems that create gentle rains of luminescent droplets, or habitats with multiple levels of gravity within the same structure, or habitats that slowly change their internal environments over seasons that last for years. The diversity wouldn't just be environmental, it would be biological and cultural as well. Over thousands of generations living in different environments, human populations would naturally adapt and change. Humans living in low-gravity environments might become taller and more slender. Those living in high gravity might become shorter and more robust. Those living in environments with different atmospheric compositions might develop enhanced lung capacity or different metabolic processes. But the changes would go beyond physical adaptation. Different human populations would develop different cultures, belief systems, art forms, and ways of understanding the world. Imagine the music created by humans who live on a world where sound travels differently due to atmospheric composition. The harmonics and rhythms they develop might be impossible to create or appreciate on Earth, but they would seem natural and beautiful to people who grew up with them. Imagine the visual arts developed by people who see different spectra of light, or who live under skies with colors that don't exist on Earth. Their paintings and sculptures might use colors and techniques that are meaningless to Earth humans, but profound to those who share their environment. Imagine the philosophies and religions that would develop among people who can see the galactic center as a brilliant bulge of stars in their night sky, or who live on generation ships and think of travel and journey as the fundamental metaphors for existence. Dr. Paul Davies, an astrobiologist, has written extensively about how different environments would shape human culture and consciousness. He suggests that a galactic civilization would be like a vast experiment in human potential, with millions of different populations exploring different ways of being human. Some human populations might develop ways of thinking that are adapted to the incredibly long timescales of galactic civilization. They might learn to plan and think in terms of millions of years, developing patience and perspective that would seem almost godlike to us. Others might develop enhanced abilities for spatial thinking, adapted to life in three-dimensional space habitats where up and down have no meaning. They might navigate by magnetic fields or stellar positions in ways that seem like magic to planet-bound humans. Still others might develop new forms of communication adapted to the vast scales and long timescales of galactic civilization. They might learn to encode complex ideas in signals that can survive transmission across thousands of light years, or develop cultural practices that allow knowledge and wisdom to be preserved and transmitted across hundreds of generations. But all of these populations would still be connected by the slow, patient flow of information across the galactic communication network. Stories, discoveries, art, and knowledge would gradually spread from world to world, creating a shared galactic culture that would be incredibly rich and diverse. This sharing of knowledge across vast distances and timescales would lead to something unprecedented in human history: the accumulation of wisdom and knowledge across millions of years of continuous civilization. Right now, human civilization is only about 10,000 years old, a tiny blip in cosmic time. Most of what we know has been discovered in the last few centuries, but a galactic civilization could potentially last for billions of years, accumulating knowledge and wisdom across time scales that make human history look like a brief moment. Dr. Seth Shostak from the SETI Institute has calculated that a civilization with a million-year head start on us would have technologies and capabilities that would seem like magic to us. A civilization with a billion-year head start would be almost godlike in their capabilities. But a galactic human civilization wouldn't just be one species becoming incredibly advanced. It would be millions of different human populations, each contributing their own unique perspectives and discoveries to the collective knowledge of the galaxy. The scientific discoveries alone would be mind-bending. With humans spread across millions of different environments, we would have natural laboratories for studying every possible variation of physics, chemistry, biology, and consciousness. We might discover forms of life that exist in the cores of gas giants, or in the vacuum of space itself. We might find ways to manipulate matter and energy that are impossible to study from our current limited perspective on Earth. We might discover new fundamental particles or forces by studying the extreme environments near black holes or neutron stars. We might learn to harness energy sources that we can't even imagine today, or develop technologies that manipulate space and time itself. The mathematical and scientific concepts developed by a galactic civilization might be so advanced that our current science would seem like children's games in comparison. They might have theories that unify all the forces of nature, or understand consciousness in ways that allow them to directly manipulate and enhance mental abilities. We might even discover new forms of consciousness, ways of thinking and being that are only possible when your mind is distributed across multiple bodies, or when you can think on timescales of thousands of years, or when you have direct access to the collected knowledge of billions of individuals. Some researchers have speculated that advanced galactic civilizations might develop forms of collective consciousness, where individual minds can temporarily merge to work on complex problems or share experiences directly. Others suggest that they might develop artificial intelligence so advanced that the boundary between biological and digital consciousness becomes meaningless. Humans might transfer their minds to substrates that can survive for millions of years, or merge with AI systems to create hybrid intelligences with capabilities we can't currently comprehend. But perhaps the most profound change would be in how humans understand their relationship with the universe itself. Right now, we think of ourselves as tiny, insignificant beings in a vast, cold, uncaring cosmos. We see the universe as something separate from us, something we study and explore, but not something we're truly part of. But a galactic civilization would change that completely. When humans have spread across a significant portion of the galaxy, when we're actively shaping stellar evolution and galactic structure, when our activities and decisions affect the development of entire regions of space across millions of years, then we become not just observers of the universe, but active participants in its development. We would become, quite literally, the universe becoming conscious of itself. Dr. Carl Sagan expressed this beautifully when he said, "We are a way for the cosmos to know itself." But in a galactic civilization, this wouldn't just be a poetic metaphor, it would be a literal truth. Human consciousness would extend across light years. Human activities would shape the development of stars and planets, and human decisions would influence the destiny of an entire galaxy. This raises incredible questions about responsibility and purpose. What would be the goals of such a civilization? What would they consider important? How would they make decisions that affect the lives of quintillions of people across millions of years? Some researchers suggest that galactic civilizations would naturally focus on what's called existential hope. Long-term projects aimed at maximizing the potential for conscious experience and flourishing throughout the universe. This might include projects like preserving and cataloging all possible forms of life, creating new forms of art and beauty that are only possible on galactic scales, or even attempting to communicate with other galactic civilizations in distant galaxies. Dr. Anders Sandberg from the Future of Humanity Institute has calculated that there might be thousands or even millions of galactic civilizations scattered throughout the observable universe. A mature galactic human civilization might spend much of its energy attempting to make contact with these other civilizations and participate in what could be called a cosmic community of galaxy-spanning intelligences. The methods for such communication would be mind-bending in themselves. Rather than radio signals, galactic civilizations might communicate by manipulating the light output of entire star systems, creating patterns that can be detected across intergalactic distances. They might build massive structures called Alderson disks or Dyson swarms that collect the entire energy output of stars and can be detected by their unique infrared signatures. These structures could serve as both energy sources and communication beacons, allowing galactic civilizations to signal their presence to others across millions of light years. But the most incredible possibility is that they might communicate through modifications to the cosmic microwave background radiation, the afterglow of the Big Bang itself. Dr. Stephen Shu has calculated that sufficiently advanced civilizations might be able to encode messages in this background radiation, creating a kind of cosmic internet that spans the entire observable universe. Imagine being part of a galactic civilization that's engaged in conversations with thousands of other galactic civilizations scattered across billions of galaxies, sharing knowledge and perspectives across distances and timescales that make our current concept of international communication seem quaint. These conversations might take billions of years to complete, with each exchange of ideas requiring millions of years to transmit and respond to. But the knowledge shared in such exchanges would represent the accumulated wisdom of entire galaxies full of conscious beings, refined and developed over cosmic timescales. The topics of conversation might include fundamental questions about the nature of reality, consciousness, and existence itself. Galactic civilizations might share their discoveries about the deepest levels of physics, their insights about the meaning and purpose of consciousness, and their experiences in creating vast cosmic communities. They might collaborate on projects that span multiple galaxies, perhaps working together to understand and influence the large-scale structure of the universe itself, or to ensure that consciousness and complexity continue to develop even as the universe expands and cools over trillions of years. But let's bring this back to something more personal and immediate. What would all of this mean for you as an individual human being? In a galactic civilization, your life would be embedded in contexts and purposes that extend far beyond anything we can currently imagine. The choices you make and the work you do wouldn't just affect your immediate community or even your planet. They could potentially influence the development of entire star systems across thousands of years. You might choose to become part of a terraforming project that will transform a dead world into a garden planet over the course of centuries. Your great-grandchildren might be the first to walk under an open sky on a world that you helped design and create. The terraforming technologies available to a galactic civilization would be incredible. They might be able to move planets to more suitable orbits around their stars, or modify planetary atmospheres on massive scales to create perfect conditions for life. They might develop techniques for creating artificial magnetospheres to protect planets from harmful radiation, or for seeding worlds with carefully designed ecosystems that will develop and evolve over thousands of years to create diverse, stable biospheres. Some terraforming projects might be so vast that they span multiple star systems, creating networks of habitable